Hello, and welcome to Modeling Linear Equations. Okay, so I know that word problems is something that students have hang-ups about, but if you approach the problem correctly and you have practice, it's definitely something that you can master. So many cases, real-world situations, can be modeled by algebraic expressions, equations, inequalities, etc. This is what math looks like outside the classroom window. Scientists, engineers, etc. use modeling to be able to understand the real world around us, as they've done for centuries. So here's a quick example. Susie ran a race. She ran 5 miles per hour. The race took T hours to complete. How many miles long was the race? Well, if she's running 5 miles an hour and the race took 5 hours, it makes sense to multiply the rate, 5 miles per hour, times the hours it took to complete, T. That will give you how many miles long the race was. So I just did that in my head, and I'll write that down right now. I just did that in my head, but so that's 5 and T. That expression right there, 5T, that's how long the race was. Now, like I said, I just did that in my head, but you can 100% and absolutely use sort of steps along with operational symbols and sorting the problem through to be able to at least get an initial understanding of how to set up a word problem. So let's jump right in. Here are the steps. We're going to use something called a verbal model to be able to model equations and inequalities. So step 1 is to write the verbal model of the problem. We'll see what that looks like in a moment. Step 2, substitute the values given in the context of the problem into that equation that you created. The verbal model looks like an equation. Specify then any unknown quantities with the variable. And then step 3, either solve, evaluate, or graph whatever the problem is actually asking you to do to the model itself. So let's take a look. Okay, so let's see what this verbal model situation looks like in practice. So here's a problem. The school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying the loan, the club has a profit of $100. How many people attended the play? So what you're doing is setting up an equation that models this situation, and we're using something called a verbal model here. So this is what a verbal model looks like. I'm using boxes to denote the coefficients and then also the other components of the terms in the equation. So in this case, I am saying the ticket price multiplied by the number of people who attended, subtract the amount of the loan, that equals the profit. Now, coming up with this verbal model, including where the boxes are placed, the operational symbols in between, that's something that you have to come up with. Kind of guess and test a bit. Use logic. This is the part of word problems that requires practice. We're going to go into in future lessons different phrases and words that define the operational symbols in the problem, including equal sign, subtraction, multiplication, addition. But you just have to read and analyze the problem and try to come up with this model and what makes sense. The ticket price times the number of people who attended. That's the total amount of revenue that the play is generating. But this school then also borrowed some money, a loan amount, to be able to pay for the actual putting on the production. So you have to subtract that amount, and that is what is equal to their total profit. Okay, then the next step here is to look at the problem. What information were we given? What is unknown information? In these boxes, if there is a one variable equation, like all of these are in this unit, or in this lesson, I should say, then all of the boxes besides one are going to be filled with numbers from the problem. And then there's one that's going to be left over, which is an unknown, which is what you're solving for. How many people attended the play? So you're going to take that same verbal model in boxes and then fill in the given information that we have. So let's see what we're given. The school's drama club charges $4 per person. That's my ticket price. So I'm going to write that in. 4. The club borrowed $400 to pay for costumes. That's my loan amount. $400. And props. After paying back the loan, the club had a profit of $100. So that's my profit. How many people attended the play? Well, what's left? That's my unknown amount. So I'm going to call this X. Now you can call this P for people. You can call it whatever you want. But that is my substitution for all the given information in the problem and then for that unknown amount that we're solving for. So last step, solve it. 4x minus 400 minus, oops, $4x minus 400 is equal to 100. So we're solving that equation. This is a simple multi-step equation that we all should know how to solve in our lives. Add 400 to both sides. Sorry, still getting the hang of this pen tablet. Stay with me. Add 400 to both sides. This is 500 on the right hand side. And then 4x over here. Just extend my page so I have a little bit more room. Okay, divide both sides by 4. Divide both sides by 4, and you get x is equivalent to 500 divided by 4 is 125. So it's 125. But that's not how you want to leave it. You don't want to leave it just as 125. Word problems always have context. What is it 125 of? I have no idea. Always when you're writing your final answer, make sure that you're discussing that number that you get, and you're evaluating x for in this case, in the context of the problem. The problem is asking how many people attended the play. So it's not just x is equal to 125 and I'm done. The final answer here is 125 people. Okay, so I'm gonna circle this as my final answer here. Yes. Okay, and we're done. I have every confidence that every student can do problems like this, setting up verbal models successfully with practice. Goodbye.